So hey, hello everyone, and I welcome you all to APJ Academy, where we are nurturing the young minds to become engineers and scientists just like you. So आज मैं आपको यहाँ पर semiconductors करवाऊंगा. So I'll be teaching the semiconductor, but before starting, I would like you please rate the quality of our broadcast, this video, from 1 to 10. If you are feeling that my audio, video, everything is perfect, just type 10. If you are feeling that something is lacking, if you are feeling that my face is not good, or you are seeing that the audio or video quality is not at its best, then you can rate accordingly. So do it fast, then we will be moving ahead. And also, after rating the quality of broadcast, I want to know that how your preparation is going on. Is it at its best? If it is at its best, you can rate it 3. Okay. If your preparation is going as per your plan, you will be thinking that like whatever level you are having, you are thinking that everything is going perfect. Just type 3. If you are feeling that something is lacking, you just require motivation, or I would be saying that it's okay. Means when you are reading the concepts, you feel that I know the concept, but the moment you started solving the questions, or started solving the DPPs, you feel that, oh, what it is, I'm not able to solve any question. So you can type 2. And if you are feeling like you do not know anything, what's going on and what is IIT, and I'm feeling that I won't be able to crack IIT this time, I'll be taking the drop and I'll try next year. So then you can press 1. We'll be assuring that we will help you and provide you every content which is required to crack IIT in this attempt only. Okay, so please rate it. So Rajeshwari is here. Rubika, good. So it's 2 is fine. Why we are here? We are here to improve your quality, right? So before moving forward, let me introduce myself. My name is Manoj Kumar. I am physics faculty of APJ Academy. I did my engineering from IP University, Delhi. The main branch from where the main branch was electrical and electronics, and I was previously associated with very renowned academies in online and offline institutes. So, and I guided successfully more than lakhs of students, I could say. Okay, in the online mode, I got the opportunity to be associated with the best institutes. So I guided more than lakhs of students and helped them to crack the toughest exam in India. And I'm passionate about the physics, so that's why I'm here. So today I'm going to teach you semiconductor, and this is very important chapter. This is a chapter which contains the concept as well as the facts, and you need to remember all these things. In the earlier chapters, the condition is like there is only concepts. The factual things are very less, and you feel there are so many numericals, so you would be feeling that yes, you know these things. But in this chapter, the concepts are very deep, right? The facts are here, and numericals, I would be saying that there are very few numericals that came in this semiconductor chapter. So today we'll be solving some previous year questions as well. So let me revise you what we did in the last class. Okay, hi Madhu, hi Vinit, Samant, hello everyone, good evening. Okay, and do let me know from which states you are, and are you comfortable with English and all these things. Okay, and the moment you feel that you are lacking somewhere, you can ask me questions. Okay, so let me introduce what is semiconductors again, because in the last class there were very few students, and it's my duty that I would be making you to revise these facts, because these are very important before we proceed for the today's class, right? So I told you that if I classify elements, there are 118 elements. I can classify these elements in 3 categories: based on the conductivities, right? The first one is the conductor. Conductor are the materials which is having a property, like if I place the conductors in electrical field, they would start moving their electrons. The free electrons are very much there, right? So there is very hard control we can do. Hardly we can do anything to control the flow of electrons. If we tell about the if we tell about the insulator, if we talk about the insulator, then what would happen? They will not move their electrons at all. Why? Because they do not have any free electrons. So there will, when there is no free electrons, there is no talk about that whether it will flow or not, right? There are so many students who would not be sitting for the IITs because they would be feeling that IIT is not our cup of tea. There are so many students who would be sitting for the IITs and they are fully charged that I would be going there. But there are so many people who are like they want to go to the IITs, they want to go to the other colleges as well, right? So we have other category as well, which is known as semiconductor. These are the materials which are extensively used in the electronics industry, I would be saying. Okay. The main advantage of semiconductors is that we can control the number of electrons flowing through the material, as well as I can control the rate through which it is flowing. Okay. So if till now I think that it is clear, the main thing why we are studying the semiconductor is the control. I can control it. Just like my wife can control me. In the material, we can control the flow of electrons and the rate of flow of electrons in the material. So the basic important property why we are using this semiconductor is the control, right? Earlier we used vacuum tubes in the first generation of computers. Those were very bulky. Semiconductors are very, very small. It's like I'm carrying a smartphone which can do anything, right? Vineet, yeah, I'll be doing Vineet in between the lectures. Okay, so I can classify semiconductors in these categories. First one is the elemental semiconductors. As we know that the element means it is pure, right, Vineet? Like we have hydrogen, chlorine, sodium. So element means it's pure. So we have pure semiconductors. I'll be showing you that how semiconductor looks. It's silicon, germanium. Okay, so these are pure semiconductor. And the other name of these types of semiconductor, if you have studied, please let me know. These are also known as intrinsic semiconductor. Okay, and the other things means if we combine some other materials with these elements of semiconductors, then it would become a compound semiconductors. So compound semiconductors examples are further divided into, like there are inorganic, there are organic, okay, and there are organic polymers. So these are the examples which you can see, right? But in our course, we will limit ourselves to the elemental semiconductors and to the inorganic semiconductors only. Okay, so we have to limit ourselves. If we talk about any competitive exam, it is not important how much you know. It is also important that what other things you are missing out, isn't it? And what you do not need to know at all. Vineet, Madhu, is everything fine? I think that it is very much clear to you that there are elemental semiconductor, there are compound semiconductor. Compound semiconductors are further divided into three categories: inorganic, organic, and organic polymers, right? Well, we will limit ourselves to the inorganic only. We'll be dealing these semiconductors in future lectures. Okay. And for the PDF, you can join our Telegram group. It's the link is given below. So let me briefly describe the band theory again. This we have already discussed in the last class, but it is very important because I'll be taking you further from this band theory, and we'll be discussing some more detail about this semiconductor. Okay, so Madhu, in the last class we have discussed that if we talk about an isolated atom, and I took an example of sodium. So if I am having only one atom of sodium, single, I would be saying, better. Okay, so the electronic configuration of sodium will be 1s, 2s, 2p, 3s, 3p. Okay, so it will be 1s2, 2s2, 2p6, 3s1. Okay, so this will be the electronic configuration of sodium. So I told you that if I'm talking about the electronic configuration of sodium, then it means that there are different energy levels. Like this is energy level 1, I can say this is energy level 2, this is energy level 3, this is energy level 4. So there are 4 energy levels in sodium atom. Are you getting it? So I can draw this energy level just like steps we have in our home, the stairs like thing. So I'll be drawing this. This is 1s energy level, this is 2s energy level, this is 3s energy level, 3p, 2p. This is 3s energy level. Okay, and there are different number of electrons in all these energy levels, I would be saying. So there are 2 number of electrons in 1s, there are 2 electrons in 2s, there are 6 electrons in 2p, 3, 4, 5, 6, and there is 1 electron in 3s. As you know, the last shell or the last energy level will be known as valence energy level. Okay, so the last energy level is known as valence energy level. So this is for first, I would be saying only means this is for isolated atom or the one atom when I am having only the sodium atom. So this will be the condition. Now you might be asking, sir, how we can be there? Means you are teaching us. Are you teaching us chemistry? No, I'm teaching you only physics. And if I'll be dealing with physics, then I should be more teaching you the potential energy and all these stuffs, right? So I'll be discussing something through which you would be able to understand why we are drawing these facts. Okay, so I hope that you know that if I am having a two charge, one charge is q1, other charge is q2, and they are separated by a distance r, what will be the potential energy? What will be the potential energy? It will be k q1 q2 by r. I hope that you know this. The potential energy of two charges when they are separated by a distance r will be like this, right? If I am talking about an atom, if I am talking about atom, and atom consists of z, z means the number of atomic number, right? So it would be same like the number of protons the electrons is having. So I would be saying that there will be z e plus number of positive charges, and there will be e minus charges here. Okay, then the radius will be r, then the potential energy will be k z e square divided by r. And if I'll draw the graph of u, I'll be getting this graph. Okay, I'll be getting this graph, and if I am very close, then the energy level is very low. If I am very close to the nucleus, the radius is very small, then the energy level is very low, similar to the like this 1s1. If I am going far, then the energy level will increase, right? But the gap between the energy levels keeps on decreasing. The gaps between the energy levels keeps on decreasing. Here, the energy gap Eg1, and if I am taking this gap as Eg2, then I would be saying that Eg1, gap between 1s and the 2s is very large as compared to the gap between 2s and 2p. Okay, so the gap between, so this will be the condition, right? This is for only isolated atom, and I am moving towards some other atoms as well. So like I'll going towards the material when we will be having n type, n atoms of sodium. Okay, Vineet, Madhu, Rajeshwari, is everything fine? Please like the session. Please like the session. If you are liking it, please like the session. This motivates us to give you more sessions like this. Okay. So let's move. And I told you that if I am considering n atoms of sodium in sodium vapors, because why I am considering vapors, because in vapors the atoms are not very close and they would be not influencing the others' energy levels. They would be settling down on their own, right? So at lower temperature around 0 Kelvin, they would be settling. So if there are n number of atoms, different atoms will be having different energies. Each will be having the 1s energy level, right, individually. It's like you are in class 11th or 12th, or in JEE I would be saying, right? So there are so many students who are in class 11th or who are in class 12th. If I'll combine all these students of class 11th, class 12th, or who are the droppers for JEE exams, then there would be one band. I explained you yesterday using the strings, right? I told you that if there is one energy band, then you would be seeing only this thing. If there are n number of atoms for 1s, you would be seeing bands like this. So it will become band. I hope that you might have seen the friendship band, whereby so many youngsters during friendship day, you would be imagining when you will be in the college, you will be thinking about that, oh, there must be a time when you will be getting these friendship band, isn't it? Madhu, Adarsh, Prasad, Vineet. So for n atoms, there will be bands, like bands of 1s. There would be n number of atoms. So there would be n energy levels of 1s. So 1s will become band. And there will be 2s band. I hope that you are getting. Then there will be 2p band. Then there will be 3s band. Okay. So this is how the bands form, and we will be dealing with this band only. So I wanted to give you the basic idea about the band, and now we will be discussing the band theory in details, right? So I hope that this is clear. Okay, Vineet, thank you so much. Yeah, Akarsh, I'll be explaining the concept of doping in this lecture only. So please wait. First, I have to explain the band theory, right? So in the band theory, I show you that the last band which we are getting, which is full or the partially full, can be stated as valence band, right? So in our sodium example, the 3s band is the valence band. The 3s band in the sodium example is valence band, right? And just after this valence band, the next band which will come will be known as conduction band. Okay, so here's the sequence. First, 1s, 2s, 2p, 3s, 3p, 3d, right? 4s, 4p, 4d, like this. So first of all, we are having the 1s band. This is completely full. Then we are having this 2s band. This is completely full. But we are not talking about the full band, right? Because they are already full. So what we are talking about, the valence band, the last band. So the last band is known as valence band. For the sodium, the atomic number was 11. So the last band was 3s. So this is valence band. Okay, so I'll be using some shortcuts to represent this valence band. So from now onwards, I'll be using the VB. So VB is known as valence band. So write it down in your notes so that when we are discussing this, you will be able to understand. So valence band will be given by this VB, and the next available band will be known as conduction band. The next available band is known as conduction band, and below this, what will happen to the bands which are below valence band? These are full band, right? These are all filled band, I would say. So we are not talking about these bands. Right, done. Shall we move? You can give the tap. Vineet, you are in 9th class. Okay. Basically, you have to follow HC Verma if you want to crack JEE exam. So I would be recommending that you would be following the HC Verma book, or DC Pandey book. You can go. And other than these two books, you will be you must have the previous year question paper. Okay. So these are the only 3 books which you require. And other thing is our material. Okay, so the assignment which I am giving is the best thing which you can solve is my assignment. Okay, so I am moving forward now. I can categorize insulator, semiconductor and conductor using this band theory as well. How? So how you can differentiate between the conductor, insulator and semiconductor using this band theory? Yeah, I can. See how I can do. As I know that insulators are the instruments which do not have free electrons and which will not be conducting at all, even at high electrical field or the high potential if I am applying. Unlike insulator, the conductors are the one which will start conducting even if I'll apply a very small voltage. The moment you apply the voltage, the electrons in the conductors will start moving, right? So I'm having the conductors here, and the other thing is semiconductors. So till now, when we are talking about the insulator, semiconductor and conductors, we were mainly discussing about the number of free electrons and the conductivity of electricity and heat, right? These were the only 2 points which we will be writing when anyone talks about the semiconductor, insulator and this conductor. But from now onwards, I am adding 1 point as well. The other point is that the gap between the valence band and conduction band in insulator is very high. Okay. So the band between the valence band and conduction band in insulator is very high. So even if I increase so much temperature or the so much voltage, the electrons from the valence band would not be able to move to the conduction band. Only when the electrons moves from conduction valence band to the conduction band, then only I can say that it can conduct the electricity. Are you getting it? Or just take an example that if I'm standing here, okay, and I'm seeing that there is one roof which is having a height of I'll say that 15 feet. Okay, so there are very less opportunity, or I would be saying that there are very less chance that I can jump from here and jump to 15 feet. So similar case happens to the insulator. The gap between the valence band and conduction band is so high that hardly it would be able to goes to the conduction band. So that's why we say that in insulator there is no conduction, right? But if I am talking about the conductors, then the valence band and conduction band are overlapping. They are overlapping. So when they are overlapping, they can go or move freely, right? They can move freely. So even when the voltage, the applied voltage is very less, they'll be conducting, right? I'll give you a fun example again. Imagine that you are standing on your roof and just your friend's roof was also there, right? And your friend's house is adjacent to your house, and the distance between your roof and your friend's roof is very less. So you can move from your home, your roof to your friend's roof very easily, right? Isn't it? So this is the case of conductor. You can move from here and there. And in what happens in the semiconductor? The semiconductor are the materials which is having the energy gap. The semiconductors are the material which is having the energy gap just between the insulator and semiconductor. So it's like when we increase the temperature, we are giving the so much energies to the electrons, then only they can go to the conduction band. Okay, so in this chapter we will be mainly dealing with this semiconductor. I hope that you are getting this, and this diagram is very important. If you are preparing for the board exam, then this diagram is very important, and you have to draw this diagram. But if you are preparing for the JEE, then you should know that what it is. And as you know that energy is equals to E h c lambda. H is Planck's constant, right? C is the speed of light and lambda is the wavelength. So if these energies need to be absorbed by these electrons so that they can go to the conduction band. Okay, Vineet, Akarsh, Madhu, I hope that this is clear. Can we move? So let me know, my army, that we can move. So I am moving ahead, and let's solve one question. This is very important question. Just now I told you the formula which is required to solve this question. The formula which is required to solve this question is E is equals to hc by lambda. This is the formula which you have to apply. Okay, so what the question is saying, I'll be explaining. The energy gap of silicon means in silicon we will be having a valence band, also we will be having a conduction band, right? And the gap between valence band and conduction band is 1.14 electron volt. So this is the band gap. Okay, so this is basically the energy gap. So what is the maximum wavelength at which silicon will begin absorbing energies? So using this formula, lambda will be hc by E. right? So you need to put the values. H is Planck's constant, C is velocity of light, and E is given here, right? And the value of E is 1.6 into 10 to the power of minus 19. So put this value and let me know what is the answer. Akarsh, Vineet, Madhu, and do let me know that whether you solved this type of questions earlier or not. Have you solved this? And do me one favor, when you are attending the class, please let your friends also know that from where you are attending these classes, because APJ Academy is giving you so many free classes, and they are also giving you so many free questions. Daily practice sessions are going on. So subscribe this YouTube channel and also join our community on Telegram channel, and keep tracking that when I am having a class. So whenever I am having a class, you can attend my class. I'm taking class on smartboard, so it would be very interactive session. Okay, just let me know. Akarsh, E is already given, Madhu. E is already given 1.14. Electron, small, if you are asking about this electron, you need to replace this. So the value of this is 1.6 into 10 to the power of minus 19 coulomb. So this you need to replace it. No, no issues. Is there anyone who can solve this question? Oh, wait a minute. Electricity is gone, I think. Wait. I'll be doing something. So Madhu, are you able to solve this? Just give me one moment. So I hope that I'm live again and you all are able to see me. Please rate the broadcast. Please rate the broadcast. Madhu, is everything fine? You let me know that is everything fine. Yes, Madhu. Okay. I hope that you are able to listen me, right? So please rate the rating of broadcast, that is everything fine or not. Okay, so this we had already done. We are done with this. So we were at this question, and I have to solve this question for you because I found that none of. Okay, you all joined. So fine. So we were at this question, and I told you that in the question it is given like that. We have one valence band. So I'll be using this shortcut for the valence band VB, and there is conduction band, right? So the gap between the valence band and conduction band, the gap between the valence band and conduction band is 1.14 electron volt. So Eg is equals to 1.14 electron volt, right? This is given. And I also told you that what is the formula we have to use while solving these type of numericals. So the formula is E is equals to hc by lambda. H is the Planck's constant, c is the velocity of light, and lambda is the wavelength. So we have to find out the lambda here. So lambda will be hc by E, right? So h value is 6.6 into 10 to the power of minus 34, and the value of c is 3 into 10 to the power of 8, and the value of E is it's already given 1.14. We have to replace the value of electron as well while solving these types of questions. So the value of electron is 1.6 into 10 to the power of minus 19. So once you solve this, you will get the answer, and that will be our wavelength, right? So the required wavelength will be the solution. I hope that it's clear. Hello Prashant Mishra. So Mishra ji, welcome. Good afternoon. I hope that it's clear now how to solve these types of question. Okay. And the answer to this question is 10888 angstrom. Okay. So this is the answer. So please solve this question, and later on you can verify that whether you are getting this answer or not. Okay. Wait, again light gone. I'm starting it again. Let's see, will it work? If it not work, I'll be moving towards the pen tab. Okay, because light is fluctuating. Just wait. I'm starting. So I hope if you have any question, you can ask me. And in the meantime, you can share this session with your friend as well, because you can tell them that now Manoj sir is with APJ Academy, and you can attend Manoj sir free classes on YouTube. Right. So we were at this. I have some JEE previous year question as well. So for doing the JEE previous year question, we have to complete some topics as well. Madhu. Okay. So I think that now everything is fine. We are done with these slides. So this is done, this is done, this we already done, this we recently solved these questions. So now what is important, that you, if you are liking my classes and you do not want to miss my class, then you have to join our Telegram group. Why this Telegram group is very important? Because here you will be getting the PDF material, the free classes, just like that. Here I am providing the free classes, the announcement, important announcement about our courses, about our classes, and the prices. Okay, and as you know that if you are buying the course from APJ Academy, you can use my code, which is Manoj JEE, right? So you can use this QR codes to scan, or just take the screenshot, or you can type this ALT JEE to join our JEE channel. Okay, so now before moving further towards the intrinsic semiconductor and extrinsic semiconductor, I would like to give you brief about the periodic table, because this is very important to know that what is doping and how doping is done. So this is the complete periodic table, and I hope that you remember all the periodic tables. Even if you do not remember, I require these three groups in this chapter, and I'll be giving you some tricks to remember these. So I require this group 14. This will be my main group for our syllabus, because we will be discussing mainly silicon and germanium as intrinsic semiconductors. Okay, and the other groups will be 13 and 15. And I want you that you should know the sequence of all the material, all the elements which are coming in group 13, and all the I would be saying all the properties of this group 13. So the trick to remember group 13 is, how you can remember group 13. If you say group 13, you are getting the feeling of 30s when you are entering into the age of 30s, isn't it? And if you are entering into the age of 30s, it might be that your hairline receding, and if your hairline receding, you need some oil to get it back, right? There was a movie which came recently on this phenomena. So for this group 13, there is trick to remember, which is Balgain tail. BALGAIN and TL. So this is the trick which you can through which you can remember the group 13 in a very in a sequential manner. So I am telling you that if you are you have to remember the group 13. You can think of that you are in 30s and your hairline residing. So what is required? You require Balgain tail. Hairs is known as Bal in Hindi. Prashant Mishra, is it clear? Madhu, I hope that you are getting this. So please remember this trick. Like, if you are liking this trick, give me the dab. And the next thing, we will be moving towards the group 14. The trick for group 14 is, generally the degree courses are of 3 years, but special degree courses are of 4 years, right? Like if I'm talking about the BSc nursing or the MBBS, BTech, MBBS is a little bit more about little bit more from 4 years. Okay, so very useful. Okay, So group 14 is the best trick to remember. This is college sister getting some problem. When you are entering into your college life, group 14, I would be saying that 4 years, no, 4, because valency is 4. Tetravalency is known as, this is also known as tetravalency. So you can say college, C stands for college, SI stands for sister, college sister getting some problem. Okay, so college sister getting some problem. So this is how you can remember this group 14, and we will be mainly dealing with this silicon and germanium in this in these lectures. Okay, so group 14 is very easy to remember when you are entering into your college life for BTech. After cracking the JEE exam, you will be going to do BTech, and BTech is of 4 years. I think, Madhu, you are enjoying it. Okay, so group 15 is very, very important. And the trick to remember this group 14 is, there were so many 5 stars people in India, and there was culture known as 5-star culture, the VVIP culture. So 5, valency would be 5, pentavalent. Group 15 elements are pentavalent. Group 13 elements are trivalent. Group 14 elements are tetravalent, right? Based on its valency. So I can say group 14, the easiest way to remember this is Nana Patekar. I hope that you remember there is a very good Indian actor, Nana Patekar. So Nana Patekar, NP, Aishwarya Rai, Sub, SB, Bimar. Bimar means disease, not well. तो नाना पाटेकर, ऐश्वर्या, सब बीमार. याद कर सकते हैं? कैन यू रिमेंबर इट? इट्स वेरी इजी. मधु, प्रशांत, like the session if you like it. Liking, sharing is very important when you are joining the live classes, because this is giving you the feel of APJ Academy, how our paid classes are, right? Can we move? Okay, so if you are done with this, we can move further. And I have to teach you something. Again, the light got some sort of uneasiness. No issue. We will start it again. Have some patience, guys, because today I am facing some electrical issues at my home, and the inverter is fluctuating with the voltage. And whenever there is voltage fluctuation, what happens is that it restarts. Okay, so have some patience, and thanks for your patience. This is our template. This is our PPTs, and if you want these PPTs, you can join our Telegram group. So Madhu, are you in our Telegram group? Have you joined? Wait. You are from Tamil Nadu, right, Madhu? It's done. Okay. Okay. So before coming to the questions, I would like to introduce you, not yet going to join. Okay, Madhu, please join that group. Okay. So I was discussing the semiconductors. Semiconductors can be classified into two parts. One is the pure semiconductor. The pure semiconductor are also known as elemental semiconductors, right? And in our syllabus, we have to mainly discuss the group 14 semiconductor, and which is mainly silicon and germanium. These two semiconductors are only in our syllabus, and these belongs to group 14. And can you tell me that what is the valency of group 14? Please do let me know. Please give responses regularly so that you will be more attentive while attending the classes, and it will be benefited. You will be getting the most benefit from these live classes only when you are typing, because all your brain got ignited. I would be saying that the stimulus to the brain would be very much fine when you are replying, when you are saying something, when you are writing something, because this is how we learn, right? So pure elemental semiconductors are there, and the other thing is, this is also known as intrinsic semiconductor. Intrinsic. Then we have extrinsic semiconductor, or I can say we have compound semiconductor. Right? It's a mixture. So in mixture, I'll be having barium, basi, gasi. Okay, so these are the examples where we will mix. We will be mixing the semiconductors of one group with other groups, right? So what is the valency? I asked you one question. So the valency of pure semiconductor is tetravalent. Tetravalence means there is the valency is 4. Okay, so how the bonding will look like? It will be similar to the carbon chapter which you had studied in your chemistry classes, because this silicon belongs to the same group. So the benefit of studying the chemistry is like, if you know the group, you would be knowing that the properties possessed by the group members are similar to the properties possessed by the other members, right? So that's why we study chemistry in a group manner. So the bonding would be in this format. One silicon atom would be connected with other 4 silicon atoms, right? So this is our intrinsic semiconductor. In extrinsic semiconductor, to make the extrinsic semiconductor, we need to add some impurities. So impurities here are known as dopants. So we will be studying the doping phenomena, and I would be classifying that the extrinsic semiconductor can be classified into 2 other parts. One is P type, other one is N type. So P type semiconductor is there and N type semiconductor is there. And what is P type? What is N type, sir? Now you are saying that there are different types of semiconductor. Okay, that we know. One is, you are saying that one is pure, the other is impure. Impure means you would be adding some impurities, right? Pure means you would be considering the elemental stage which is purely available in the on the earth, right? So you told me that you will be mainly using the group 14. It's fine. Silicon and germanium would be there. Silicon is abundantly available because silicon is available anywhere. Because as you know that the sand is SiO2. So silicon is abundantly available. It's very cheap, but the energy gap of silicon is very high. The energy gap of germanium is very low. So we will be more favoring towards the germanium, right? हाँ या जॉन सीना ने बताया, जॉन सीना, जेमिनी एंड मधु. Okay. So in the impurities, I told you that while explaining the semiconductors, like we are having a group 14, right? So this is our main group. If we are going towards the group 13, then if impurities are from group 13, then what will happen? There will be less number of electrons, right? If we are adding the group 14 impurities, then there will be more number of electrons, group 15, pentavalent. This is trivalent and this is pentavalent. Okay. So just imagine that you are having a pure element that is tetravalent, right? So tetravalency I can show you with the pen. So you are having an element which is having a valency of 4, right? That is why it is known as tetravalent. So I am having a silicon atom which is having the 4 valencies, and I am attaching this silicon with other element which is coming from trivalent group, or I would be saying group 13. What are the elements from group 13? I told you that group 13 is synonym to 30s, and in 30s you will be your hairs are residing. So bal gain tail, right? Remember? So when group 13 is coming, what would happen? There are less number of electrons. The valency is less. So one would be free. Okay. So it would be, what it would become? It will become P type. Okay. So in P type semiconductor, we will be adding the group 13 impurities. In N type semiconductor, we will be adding group 15 impurities. So this is the fact which you need to remember it. Okay. I'll be explaining you this in future classes, that why this is happening, right? Let me solve some questions or give you some questions so that you will be able to get a quick grasp of the concept. So I am having one question here. An N-type semiconductor is electrically, what it is N-type semiconductor is positively charged, negatively charged, maybe positive, maybe negative, or it is neutral. So Madhu, do let me know. John, Prashant, come on guys. Here are your options. An N-type semiconductor is electrically what it is. See, if I am talking about intrinsic semiconductor, or if I am talking about P-type, N-type semiconductor, all these semiconductors are electrically neutral. Why? Because I am adding what thing? I am adding the group 13 elements. These were electrically neutral. I am adding these elements to group 14 elements. Or if I am adding group 15 elements in group 14, I'll explain. Wait. I am telling you that if I am having group 14 only, then it is known as intrinsic semiconductor, right? It is very much pure. I am telling you that if I am adding group 13 to it, this is also electrically neutral. But this is electrically neutral, right? And mixing this these two neutral things, giving me p-type semiconductor, right? And if I am adding group 15, this is also neutral, and group 14 and group 15 both will give me n-type semiconductor, and this is also neutral, right? Are you getting it? So I am telling you that group 14 is neutral. You can take any element. If it is not electrically charged, then it will be neutral. You are just adding the impurities from group 13 to make it p-type semiconductor, then the mixture will be electrically neutral. So p-type is also electrically neutral. The n-type semiconductor, when we are adding the group 15, which is electrically neutral, to the group 14, which is also electrically neutral. So when we are combining these two groups, then it will be the neutral. So the answer will be neutral. I hope that, no, Madhu. Oh, Jennifer. Okay, Jennifer, my mistake. I think that it is clear now, right? That all these elements are from the periodic table, and if they are not electrically charged, then it will be neutral only. Okay. So Madhu, in which class you are? And the other thing? Okay, Madhu. Okay, Jennifer. So other thing is, like, if you are liking our classes from APJ Academy, then I would like to suggest you that you should subscribe this channel immediately and hit the bell icon, because here we are providing you so many free classes, and the updates we are providing to from the Telegram group. And if you are subscribing it with the bell icons on, then all the notification of our classes will be, you will receive all the notification on your phone, right? And in our paid courses, for our paid courses, there are more than 90 plus classes I am taking. So it is very convenient for you to take our classes, because if you can access the internet from that device, you can access our course. It is just as simple as that. You can access it from laptop, you can access it from the desktop, you can access it from the tablets. Like I said, that if you can access the internet from the device, you can access the content from our courses. So it's as simple as this. And the syllabus from JEE experts like me, so I'll be teaching you that how JEE is asking the questions and what is the pattern change in recent era. And we are also using the flipped classroom method. What is the flipped classroom method? I'll tell you in detail. And then there is live doubt solving classes, that when you are solving our packages, DPPs, you might be getting the doubts. So I'll be here for you to assist you. And I also mentoring many students for their studies, how they should plan their studies. This is very much important, because you are preparing for the toughest exam in India for the students like you. So I'm explaining you that what is the flipped classroom. In flipped classroom, basically what happens is that we are giving you one video before starting the concepts. So I'll be giving you one video of 10 to 15 minutes and explaining you that I'll be teaching these many topics in today's class. Also with this video, I'll be giving you the study material so that you can learn whatever I'll be teaching in the main session. In the main session of 1.5 hours, I'll be taking the webinar, right? So in the webinar, mainly I'll be discussing more questions, because theory is already completed. You have the basic idea. So main focus of our is on your problem solving, how to solve the MCQs, right? So because due to the MCQs, you can only crack the exam, and in exam you can't afford to make a mistake, because if you make the mistake, then what would happen? You lose marks, right? Because there is negative marks. So in webinar, we will do a lot of practice from the my material only, and I'll also give you homework so that you can check that whether you will be able to solve that numericals on your own or not. And we will check the homework. I'll provide you the video solution of the homework as well. Okay. Then, so there are so many plans available if you want to join APJ Academy, the first plan is light plan, where we will be providing you the interactive live classes just like this class. Okay, the structured course and PDFs will be provided to you, just like I told you that before starting any course, I'll be providing you the complete theory recorded classes as well as the material. And live test will be there so that you can judge your preparation with the other candidates. Physical notes will be provided to you. And if you are buying the smart plan, then in addition of all these features, you will be getting the one-to-one mentorship. But in our live courses, in our crash courses, I would be saying, I'm providing the one-to-one mentorship to all the students, right? So you do not need to take any tension. Live doubt solving is there, and mock test regularly we will be conducting for the smart batch. For the professional, in addition of all these light and smart features, we'll be having some additional special courses just to see based on your requirements. Like if you are facing some issues in kinematics, I'll be giving you the lectures of kinematics. If you are facing some issues in mechanics, then I'll be giving you the lectures for the mechanics. Okay, so these are the features which we are providing, and this is the special price. This is the special price on which you can buy. The code which you can use is Manoj JEE. This is the code. If you are buying this subscription, then you can use this code and get our subscription, our course, I can say the iconic course of APJ Academy with this 2990. This is a very low price. I bet you that on this price you won't be getting such facilities, right? So I'm happy to announce this. So please let me know that how many of you are interested. Okay, Madhu, you are in class 11th, so you will be having some more classes till you will be reaching in class 12th and giving the JEE exam. Okay, so we will be starting with some topics for class 11th as well, the laws of motion and kinematics. So do not forget to join those classes, right? So I hope that you are clear with the pricing of APJ Academy. So if you want to chat with us, chat with the faculties of APJ Academy, you can scan this code. And if you want to see all our future updates of the class, you can scan this QR code and get all the useful files for you to get the homework, right? So we will meet again. So till now, I'm ending this class here only. I want that if you like this session, please hit the like button and share this with your friends and let them know that from where you are studying for the JEE exam, because we together create a new world where a lot of engineers will be from APJ Academy. So bye bye. We will meet you again. Bye.